Hello everyone, welcome to another session in Lead Life Code. Today we are in the fifth session of the data structure series and we will go through today two important algorithm problems that normally get asked in the interviews. So the first one is the two pointer algorithm and the second one is binary search. So in both of these scenarios or algorithms, today we will use sorted arrays. So for both the problems today, sorted arrays are the prerequisites. Okay. So let us say start with two pointer algorithm. So what does this say is here primarily we will use two iterators or indexes. So what does that mean? So let us take an array one. So in this array, we'll put some values in. So one of the problem statements that normally get asked is find two indexes whose target or sum is, let us say 14 for this example. Okay, so they will give you basically a target, that is a value, and they would want you to find two indexes or values in that array that comes up to this sum. So normally if you try to go and do the force iteration or uh, brute force here. So what brute force means is you just continue to iterate. So 1 plus 3, 4, no, 1 plus 4. So like this, if you start doing it, so that is what we call as brute force, and the time complexity becomes n square. So which is not a great solution. You will not be uh, giving the most optimized solution to this problem statement. So then how do we solve it? So let us say this is an array A. So in this, what we will start with, we'll have an I, we'll have a J. So there is, in the lowest index we'll start one iterator, and from the highest index we'll start an iterator. So basically 0 and n minus 1. Okay. So what will happen here is you will start by adding these two. So you will start if a of I plus a of j is equal to target, that is equal to 14. So in this case 11 is not equal to 14. So here you will check, is 11 greater than or lesser than 14? So here 11 is lesser than 14. So if it is lesser than 14, what you would do is you will take iterate I to I plus plus. Okay, so now what will happen is a of I plus plus, that is equal to 2, or sorry, a of 1 plus a of j stays there. So what is coming now? It is 3 plus 10 equal to 13. Again 13 is less than 14. So what you will do, again iterate the I. So then what happens, I becomes, this is 0 1 2 index. Okay, so I becomes 2, a of 2 plus a of 3 4 5, a of 5, because j is not changing. So a of 2 is 4 plus a of 5 is 10. So you got 14. So you can now give this as a, so 2 and 5 are the index where you are getting a target of 14. So there is another scenario. So in case instead of 14, so let us say here um, it was not so let us say target, we will change it to say 7. Okay, we'll change the target to 7. So what will happen is 11 is greater than 7. If it is greater than 7, then you will do j minus minus, then again j minus minus, then again j minus minus. So like that you will do. So here when you come here, j minus minus, then it will come to 6 plus 1 is equal to 7. Got it? So this is a very good explanation, or a way of optimizing a problem statement where you have to find the sum of two indexes to equivalent to a target. So here the time complexity changes from O of n square to O of n, which is very highly optimized. Let us go to the next one, that is binary search. So in binary search, which is very heavily asked in a lot of interviews, is uh, working on a rule you can think around is divide and then process. So what do we mean by that? Let us take again another array. So 2, 4, 9, 11, 15, 17, 20. So again it is a sorted. Okay, so it is again a sorted array. So let us say you have to find 15 from this array. So in brute force, how would you do? You would iterate I plus plus, and you'll continue till you reach this index. So basically here again the time complexity becomes O of n. Got it? So now in binary search, what happens is uh, you have to divide. So basically in binary search, this is the lowest, this is the highest indexed. Okay, so 0, 1, 2, 3, 4, 5, 6. Okay, so low plus high by 2, that is equivalent to 0 plus 6 by 2, 3. So you will start by dividing this parent big array into two smaller arrays of this value, that is 0 to mid, which you found now, that is mid is low plus high by 2 is equivalent to mid. So in this case it was 3, and so you will divide it into two arrays, so 0 to mid and mid plus 1 to n minus 1, or high minus 1. Okay, so okay, I deleted the example array. Let me create it again. So let us take this array: 2, 5, 9, 11, 13, 17, 20, 0, 1, 2, 3, 4, 5, 6. Let us say we want to search 13. So now, so we found first array is this 0 to mid, 0 to 3, and the second array is this. Now you will see the highest value, that is a of 3, that is the mid value. Is it greater than or lesser than your search value? So here it is 11 is lesser than 13, so you just eradicate this array. This array is no more used. Okay, not going to be used anymore. You will only use now this array. Now again you will do the same operation in this array. So here it is 4, 5 and 6. So mid is 4 plus 6 by 2, that is 10 by 2, 5. So again you will do what? You will take this array first, 0 to mid, or 4 to 5 this array, and this array. So then you will check what? Whether 17 17 is greater than 13. So you will eradicate the right hand side array. You will only process this one. So here again what will happen? 4 plus 5 by 2 to calculate the mid. So it is coming to 4, because when you are dividing, if it is coming to an odd number, we always take the whole integer number. The decimal is not considered. So 4. So now you will again check what? 13. A of 4, that is 13. Now it found equal to 13. So basically what you did, you were able to get the number by checking only 3 times. So that is why the time complexity of binary search is O of log n, because it doesn't exponentially change the processing. It changes uh, based on this division rule. Hope this gave you some better understanding on these two very important algorithms, that is two pointer algorithm and binary search. In the future sessions I will get into sorting and how to also solve a non-sorted array using two pointer algorithm. So stay tuned. Thank you for patiently listening to me, and hope these sessions are helping you to prepare yourself for the interviews and a refresher to your memory. Thank you. Please subscribe to this channel, and happy learning.